In this video, we will go through the skeleton of the projects and the folder structures for the N-tier architecture. In N-tier architecture, we split our applications or systems into different layers based on their functionality. For example, data access layer deals with the database, business logic, then service layer, and then the client side. Now, when we are developing these kind of large applications, we have to develop many projects. How do we structure those projects? What should be the folder structure and where they should be developed and how they should share different resources? So these kind of things we will discuss in this video. Okay, as I said, in an entire architecture we have a database, and on top of the database and we have data access layer. Data access layer is responsible to communicate with the database. It is responsible of connection, executing queries, getting the data back, sending the updates and everything, and what it returns to the top layer, for example BL layer, is the business objects or the results that are the results of the execution of the SQL queries. And then in BL layer we perform all our business logic. So all the business related rules are processed in the BL layer. And after the BL layer, on top of the BL layer, we have the service layer. Service layer usually exposes our business related functionality over the network, and it could be over the internet or over the intranet. Service layer should be very thin. It shouldn't have any large processing and any business kind of rules in here. What it should do, it should simply expose its functionality over the intranet or internet, and whenever a call comes from the outside boundary, it should simply delegate that call to BL layer. In the BL layer, based on our business rules and strategies, we do whatever we want to do, and if as part of that processing something has to be fetched from database or something has to be updated to database, we then invoke data access layer, which then connects to database, executes certain scripts, procedures or queries, and then brings the result back to the BL layer, and BL layer then brings the result back to the service layer, and then service layer returns the response to the client, and the client is usually here, which uses the service layer. And when we come to the client side, client is also not a simple one layer client. We have at least a controller, a user interface, and some configuration, different parts of the client as well. We can use different design patterns as well. For example, MVVM, which is quite common and kind of standard in WPF and Silverlight, and MVC, model view controller in ASP.NET. Using these kind of standards or patterns makes it easy to understand and manage the code. And we all know, if we know our clients are based on the MVVM, we know what does this layer, where is the view, where is the controller, and where is the model view. So MVVM is actually model view which stands between view and the model, and MVC is model view controller. We will not go into details of these patterns, but we will talk about the folder structures. Okay, in here I just created a folder, customer services system. Imagine we are going to develop a customer services system. So how will be the folder structure? Within the customer services system, it's a folder. We can create a documents folder where we will maintain all the documentation of the system. We can create sub folders within the documents based on our needs or our organization. How do we organize our different documents? We can create these folders inside the documents. In short, under the documents folder, we will manage all the documents, technical documents about the system. Then releases will maintain all the releases that we have done so far for this system. It may contain release notes, binary files, setups, and all these things with version numbers. Okay, then there should be a folder, source code or src, whatever you name it. This folder should contain the source files, C sharp and all these code files that we develop, that we write. Now source code we have to divide into different categories. One code is which is server side code, like services, business layer, data access layer, all these kind of layers are executed on the server side. And then there are certain layers that, like for example, our app client, if we are developing a client which is Windows application client, we will have a folder for it, and that should go underneath the client folders. And if there is another client, web client or Silverlight client on any other client, that will go underneath the client folder. Basically we need to differentiate our servers related code and our client related code. Okay, once we differentiate server related code or projects and client related code and project, then we need to know there will be definitely some common things between clients and server. For example, if we want to have all our public interfaces which are common between server and client, because server side will implement or expose those interfaces or methods and client side will consume those interfaces or methods. So both sides need to refer to these projects or these objects or these interfaces. And also we need to expose business objects as well. Business objects are which are sent across the wire, across the boundary of the processes. So when client calls a method, okay, give me the customer data or customer detail, we should be sending back an object, and that object should contain all the attributes, for example client name, its phone number, address, order details, whatever we want to send. All those details should be into one business object, and that object is now shared, because server side will build up that object and client side will receive that object and display it into some UI. So these business objects are common between clients and server. Public interfaces are common between clients and server, because server, on server side we will expose like get customer detail, and over here in the client side we will consume that method. We will have a proxy or some kind of reference to the server side, and based on that reference we will say proxy dot get customer details. So this will be referred by both the server side where we are exposing the server functionality and the client side where we are consuming the server functionality. So these kind of common projects should go under the common folder. Okay. Based on your requirement, you may modify or may enhance this structure. It's just an overview on my side. Now once we have this folder structure, all these folders are there, we can now start developing our projects. So first of all we need to start with the common things, because when we are developing this kind of system, we need to know what functionality we are going to expose over the wire or over the services, or what our client should be using. So we need to know what will be the method and interfaces and what will be the business objects that we want to expose. Once we are clear about these contracts between client and server, then we can develop our data access layer and business layer. And once the business layer, data access layer and business layer are developed, we can test them maybe independently. Data access layer should be independently testable. Business layer should be tested independently. Once we are sure like this code works fine, we can have test driven development. We can write test and that can be automatically executed, or we can write some application that can execute methods of these layers and can confirm like they return and execute fine, the results are okay. Once we are satisfied with DAL and BL layer, then maybe we should expose all the functionality to the service layer. And when we expose the service layer, we will implement or expose the interface which is into the business object, which is into the public interfaces, the common things here. In service layer, like in this layer, customer WCF, we should not put any processing. But there could be small things like how do we handle errors. So if it is a WCF service, we need to catch the exceptions from business layer or underlying layers and then throw the faults to the client. Also, if there is something to do with the security, some authentication or authorization has to be done, that we can do in the service layer. But other than this, we need to simply delegate all these calls to the business layer. And when it comes to the UI, we should at least have a controller class which is responsible to instantiate, connect to the server side, call the methods and get the results. And then we should have some UI to display the results and have some interaction with the client or the user. Okay, now we will just go through some exercise. We will develop these kind of layers and projects based on maybe one or two methods, and we'll see how all these things are set up, how the project should be developed. So let's see. So the first thing we do is we create, okay, the folders are already created. So if you want to check, these are the folders that I already have created. Customer services system, and as I said, documents folder should contain documents, releases folder should contain releases, and you can organize the way you want in here. You can maybe create more folders if you have some more items to do here. Then source code at least should be divided into these three folders. If you have more categories, you can create more folders. We have common, and in common we should define the business objects, and then public interfaces should contain public interfaces. Then server side should contain data access layer, business layer, service layer, then the host application which will host the service, and then the setups if we are going to create some setup projects, wizards, and then server side common interfaces as well. There possibly there is a need, like this business layer and data access layer exposes their functionality based on certain interface as well. So all the interfaces which are common on the server side only, like functionality exposed by the business layer or the data access layer based on a certain interface, those interfaces will come here. Because these are server side interfaces, we don't need to bring them to the public into the common public interfaces, because they won't be available for the clients over the wire or over the services. They are just accessible on the server side, so we keep them somewhere on the server side here. Then when it comes to the client side, we can create folders based on our structure or the pattern we are using, or at least there should be like UI, Silverlight UI or Windows App UI or Web UI. And if we have something common between all these clients, we can bring some common folders here as well. So in this example, the folders are already created, and then what we will do now, we will in Visual Studio we will create a solution file. So file, new, okay, we go to other project types, Visual Studio solution file. From here we select the folder. Okay, solution file, maybe we should create into here, into the source code. So when we go to the source code folder, we see the solution file and we can open it from there, and we can name it customer services system. Okay, okay, now solution file is there, and now we will start adding and creating new projects to this solution. After the solution, we will create a project, and that should be our business objects folder, and it should go inside common business objects. Okay, and in this folder we will have a project called customer services business objects. Okay, this project, it should be a Windows or a class library project. So we we make it a class library project. We should have selected when we created, but we did not select it. So what we can do, we can delete these forms and this program file, and then we can add a class. And that class we can name like customer services business object, or in fact we should give a name like customer details. So this is the class. We make this class public, and inside here we expose or write all the properties that it should contain. We can say public string customer name, and this should be a get and set property. Similarly, we can say public int order number, get and set property, public string ship to address. Okay, you can add as many properties as you want. In this example project we will just write these 3 properties. Now because we are going to expose this object over the service boundary and we will be using WCF service, so we know that if some object or composite type or complex type has to be transferred over the WCF boundary, we need to put some attributes on this layer, and that should be on the member we will put data member attribute, and on the class level we say data contract attribute. Because these attributes are not here in the domains that are already referenced in the namespaces, so we need to add a namespace, and I think the namespace is system.runtime.serialization. So if when the SOAP message is built up, the .NET serializer, it finds these attributes, and based on these attributes it comes to know which members of this class need to be serialized to be sent across the WCF boundaries. So if we want to have more attributes within this class or properties within this class that we don't want to transfer across the wire, we will simply either comment this data member attribute or will not put this data member attribute, and that property will not be serialized when the response or some parameter is serialized as part of the SOAP message in a WCF call. So simple. In business objects we need to create composite types with all the attributes and properties of those composite types, and just decorate them with these attributes: data contract and data member. Okay, now we come to our business interfaces or public interfaces. So we say add a new project and common public interfaces, customer services public interfaces. So this is our project name, and it should be a Windows class library project. Okay, we don't need to have any class in here. We need to add some interfaces. And we say customer is the interface, interface and say get all customers, and what it should return, it should return list of customer detail. Okay, now customer detail is in another project which is business objects, and we have to refer business object here, so we just add a project reference. Okay. So we have one method into our interface which is get all customer. It returns a list of customer details. Okay, because we know this interface, like iCustomer interface, will be published over the service, WCF service. So to make WCF framework aware of this thing, like with this interface is being published, we need to decorate this one with an attribute, and that attribute is service contract. And similarly, all the methods that need to be published or that need to be invocable by the client over the WCF should also have an attribute which is called operation contract. Okay, if we have more other methods which are not to be published over the WCF, then we don't need to put the operation contract attribute. And again, these attributes are part of the namespace which is system.service model. So we add this namespace here. Okay, so now we have interface with the right attribute, service contract and operation contract. Okay, so our business object and public interfaces layers are done. Okay, now let's make the interfaces which are common on the server side. So we add a new project, class library project, and this one should go to server and server side common interfaces, and customer services server common interfaces. And again, it's class library project because we will just add some interfaces to it. These interfaces will be implemented by DAL and BL layers. So add new item code interface, and so our DAL is implementing iCustomer DAL provider. And then we add another interface which will be implemented by the BL layer. Code interface, and this one is iCustomer BL provider. So we make it public as well. And let's say they all have the same method signatures that here. Okay, so this one contains this method and this one contains the same method. Okay, but in reality the DAL might have different methods with different parameters than the business layer exposes, but over here, just for simplicity, no, this customer detail should come from the business object. So we have to add the reference of the business objects to this project as well, and reference project and business object, and Alt Shift F10 should add a using statement here. Alt Shift F10. Okay, so now we have the interfaces that will be implemented by the BL and the DAL layer as well. And we don't need to decorate these interfaces or methods with the WCF attributes because they are not exposed over WCF. They are just implemented by DAL and BL. So no WCF attributes are required on these interfaces. Then we add a new project, and that new project should be our data access layer. So we say we now make a class library project. It's customer DAL, and this customer DAL project should go under servers customer DAL folder. Okay. Now it should have a class, and that class should implement the interface that comes from here, I customer DAL provider interface. So okay, we need to now refer this project into DAL. Customer services server common interfaces, so that we get a reference to this one. Okay, now the class name should be changed. We can simply say customer DAL provider. Okay, and also the file name should be changed. If we change the file name first, it automatically changes the class name here. Now we need to implement this interface. Alt Shift F10, implement interface, yes, and here it go. Okay, now this has to be referred in here. Add a reference to business objects. Okay, so now our DAL has implemented this method. If you are writing tests as well, so you can write a test class, and in that test class you can put your test for the DAL and similarly for the BL layer and execute those tests. But in here, instead of throwing exception, what I will do, I will say return a new list. We instantiate a new customer detail object, and then we set its properties. So we say customer name is item, order number is 101, and ship to address is ABC Road, London. Okay, so we can add maybe two objects. David, order number is 106, ship to address is XYZ Road, London. So now this list contains two customers, and return this list from here. Okay, but in reality we will not be creating a list like this. In del over here we should be going to the database, executing some queries, bringing back the results, and then we should, based on those results, we should prepare these customer details list and return the list, because this is just test method, this test skeleton we are going through, this example we are going through. So I just return this list from here. So our del in a way is complete. So we should have an interface for the del, implement all the methods of the del, and then implement those methods. And if we are using test driven development, we can write tests and execute tests and make sure all the methods works fine, and then we can move to our BL layer. So we will create another project, add new project, and this project should be customer BL. And this should go under server customer BL. Okay, it's class library type project, fine, public class, and this should implement the interface which is here, I customer BL provider. Okay, so first of all we refer this project into customer BL, add reference, and so we need both business object and server common interfaces. So we refer both of these projects, Alt Shift F10 using, and then Alt Shift F10 implement. Okay, now the class name should be custom BL provider instead of class 1. In your case it could be whatever suits you. Okay, I will just change the file name here and it will automatically change the class name here. Okay, now in here okay, right, now what if I do I customer del provider. If I have a del provider as a local variable into my class, so what I can do, I can simply say I customer del provider dot get customers and return. Okay, so what I'm doing here, I want to have a reference or an object which is the I customer del provider, and I will just invoke my method, or I will delegate call to the del using this. If I have some business rule to implement, so I will say apply business rules or process business rules, whatever you want, and whenever you have to make a call to the del, you just invoke del based on this interface. Now if we don't have this interface, if we do not have this interface, we should have a class object. So we should have customer del provider. We can do this as well, customer del provider as well, but that means our business layer BL is tightly integrated, is tightly depending on the del layer. We cannot really separate it. The advantage of using the interface is where we initialize this object. So say we have a method public static void initialize, and in initialize method we get this interface provider, and what we say is this dot so we say Okay, and now we write a constructor for customer BL provider. And it should take this parameter and set it to the local one. This dot del provider equals to del provider. Now imagine any client of the BL layer. In our case it should be WCF service layer, but say if any other user interface or any layer which is using this business layer, whenever it needs to initialize the object of this class or this interface, I customer BL provider, it has to provide us an initialized DAL provider object. So now it's up to the user of the BL layer which DAL that want to operate. So it has now totally isolated the DAL to the BL layer, and whoever is using the BL layer can take decision on which DAL want to use. So maybe there are more than one DAL implementation. One is the real DAL, one is the test DAL, one is something else DAL. So whenever somebody try to initialize the BL provider, he will decide, oh, I need to use the test DAL. So he will say my DAL equals to new test DAL. And when he will call the initialize method, will pass the test DAL object here. That test DAL will be set to this local object, and all the calls then coming to the BL layer will be delegated to the test DAL. So testing will become very easy with this isolation. We can obviously gain other advantages with this isolation as well. We can maintain multiple implementations of the DAL objects and similarly the BL objects as well. And if we go with the same approach with the BL layer, when we invoke from WCF, so WCF at the WCF level with just one parameter, we can decide if this call has to go to the test BL layer or to the real BL layer, the production kind of BL layer. So if the test flag is on, all the calls should be delegated to the test implementation of the BL layer for the testing purposes, and if the test flag is not on, all the calls should go to the BL layer. So by having this isolation, by working on the interfaces, not the classes, not the implementation level, we can achieve this kind of isolation and can have benefits in maintaining the code, in understanding the code, and also in testing and all these kind of things as well. Okay, one more thing we need to know here is, like, say public static initialize. This is if I'm going to write an initialize method for my DAL layer. Now imagine DAL has to work with the database, and when it works with the database, it needs to know private string, so I can say connection string, and private integer, say database connection timeout. So if you want to customize that feature, now these values, where they should come from. One option is that we use some kind of settings or configuration which the DAL knows, and DAL automatically in its initialized time says, okay, connection string, and say my settings dot connection string or get connection string. So it can invoke some API or class or some other external project to get these settings. One option is this. This way we are actually hiding the complexity within the DAL. But the disadvantage of this approach is, like, the user of the DAL, for example, the one who need to instantiate the object of the DAL doesn't know the dependencies. Like, he will not know, like, what does the my settings do. He is not aware of all these things which are hidden from that user. when he instantiates the object. So another approach over here could be like when we say initialize, we get all the settings from the one who initializes. So we say you have to pass the connection string and you have to pass the db timeout, and then in here we initialize new. Okay, we take the static instance. So we initialize with these settings. For even further uh, going further for a good design, we can again specify pass an I setting interface as well, and then whoever need to pass the setting instead of the real values or the real objects can pass an interface, I setting interface. So that interface then again can be initialized based on the development environment, based on the UAT environment settings, or based on the DAT or real production environment settings. So that kind of flexibility will be good here as well. But I will simply go for these basic parameters. But it would be good to have I settings interface which is passed here, and then in here instead of getting these values it should say settings object dot get connection string, setting objects dot get db timeout. So but let's go for these objects because we need to save time here as well. So now let's write constructor for the customer dial provider. This is all our static stuff, so we can maybe say begin static members and region. So all our static stuff goes here. Then similarly we can define member variables here, private members and public members here using these regions. So it is good to maintain and manage the code. So now we have a static method to initialize our customer dial provider, and then we have a static method to initialize our BL provider as well, and the interface implementation get all customers in both of these classes. This BL simply delegates the call to the dial provider, and this BL is isolated from the dial because we only work on this interface. We do not have any object reference from that project or from that class to here.